Hello everyone, my name is Carlos Quadros and I will present the work BioTraffic, a bio-inspired behavioral model to vehicle traffic simulation. The also authors of this work, Gianna Damati and Alessandro Bicho. This work is organized as follows: Introduction, Related Works, BioCrowds Model, BioTraffic Model, Results and Analysis. Conclusions. Introduction. The proposition of traffic simulation models requires considerable efforts. There are several techniques for modeling traffic behavior. However, existing approaches are often focused on massive mathematical descriptions of traffic flows. Existing traffic modeling methods require careful parameter tuning to obtain visually convincing results. Proposed models are limited to reproducing previously programmed behaviors. This research produced a novel traffic simulation model in virtual environments called BioTraffic. The main idea of this model is a bio-inspired agent-based method that occupies the simulation space based on available markers of the environment. The proposed model is not a new car folly, but a different and innovative way to simulate the behavior of vehicle displacement in simulated environments. The proposal is based on BioCrowds Model by Bicho et al., which proposed a behavioral model for crowd simulation. Vehicle traffic simulation models are characterized by their approaches. There are approaches to analyze traffic simulation. Microscopic models focus on agent details. Car-following model is one of the most used for the computational representation of vehicular traffic. Macroscopic models focus on the environment in general. Mesoscopic models are hybrid models working with micro and macro models. In Table 1, we have a summary with the main contributions of the related works. And now, I will present the BioTraffic model. The model was originally proposed by Runas et al. To model the development veins in plants' leaves and tree branches by disputing a plant harmony called axine. Each time the agent I moves in the simulation, it is necessary to update the position P, T, and, consequently, to target vector G, T. The set S contains all the end markers close to agent I in the simulation scenario. These markers are part of the participation area, where Si, A1, A2, and An. And now I present the BioTraffic model. In crowd simulation, each agent, in order to arrive at the desired location, contests space using markers is a resource available in the environment. The distance between markers plays a key role in two important aspects of the simulation: computation cost and realism in the agent's movement. In order to represent movement carried out by vehicles and their respective restriction, the BioTraffic proposal is based on a model with used autonomous vehicles, the Ackermann steering geometry model. In Figure 3, we have the precipitation angle agent of the markers corresponds to 2SWA. The ICR instantaneous center of rotation aims to provide an external reference point for orientation, and later collaborate with the directional calculations with the other points of the vehicle. We adopt in the BioTraffic model with a perception angle of the markers corresponds to 2 SWA and will produce the same direction effects in the vehicle reached area. The markers not only inform a spatial reference scenario, an approach that integrates the concept of theory to BioCrowds Model as proposed. The markers inform through one of their attributes by a variable called service capability, the current maximum traffic lane speed. The markers inform the displacement, availability of the agents, and the spatial coordinates are used to calculate the sum vector of the direction vectors obtained for each marker containing a personal space of the vehicle. The movement of each agent is calculated iteratively. The position p, t, and target vector g, t are calculated at each simulation step. For development, we choose the natural total model or traffic simulations. The validation of developed model is performed comparing IMSUN traffic simulator results a commercial simulator. In Figure 4, we have a BioTraffic simulator interface. In Figure 5, we have the comparison results between IMSUN and BioTraffic. Results and analysis. Emergent behaviors. In terms of simulation related traffic, lane change and emergent behaviors are important features in multi-lane simulations. When vehicles change from one lane to another, this can have the effect on a wave slowing in both lanes. The merging of two lanes away produces a reduction in capacity due to generate bottleneck. The behavior is reproduced by proposed model, just that the damaged vehicles remain with their markers. The chart increment variable is used to recharge the maximum road speed value defined in the markers. When recharging is faster, we have more lane changes. When reloading is slower, the road speed is reduced and less lane changes occur. In case of a partial road interruption, we are able to simulate the bottleneck behavior due to the merge between lanes, and returns true ones after breakpoint. In Figure 10, we have a snapshots of lane change. In Figure 11, we have a snapshot of lane merging. Through analyzing the data obtained for the model simulation IMSUN simulator, it was verified that the proposed model present results correspond to those of vehicle traffic simulator. Regarding visual results, the method reproduces characteristic behaviors in multi-lane traffic, lane change, and merging behaviors. BioTraffic is different for the more conventional model we used because it was the capacity for the new types of simulation. The interaction of the agent is made with the environment and not with other agents. In future works, I will improve the theorizing where the service capability will have different weights and the markers, to propose improvements to the model by addition georeference data from open maps and implement parallel process techniques on GPUs. Reference acknowledgement. Thanks. Questions.